Let us work the trigonometry problems I gave you in class. Here we go. In the right triangle shown below, the length of AB is 8 units. Angle A measures 60 degrees. Sine 60 equals 0.866. Cosine of 60 equals 0.5. And the tangent of 60 equals 1.73. Approximately how many units long is BC to the nearest hundredth of a unit? Well, if you know anything about trigonometry, you know that the sine of an angle is equal to the opposite over the hypotenuse, that the cosine of an angle is equal to the adjacent side over the hypotenuse, and the tangent of an angle is equal to the opposite side over the adjacent side. So they're asking for the length of BC. So if this is my angle 60, that BC is opposite 60 and the hypotenuse is 8. So I just need to choose a trigonometric function that includes those values, opposite and hypotenuse. Well, it's clearly sine. So I can say that the sine of 60 should be equal to BC, the opposite side, over the hypotenuse, which has a measure of 8. Okay. Now I'm just going to do some arithmetic here. I'm going to multiply by 8, then divide by the sine of 60. That means that BC is equal to 8 times the sine of 60. Furthermore, BC is equal to 8. They told me that the sine of 60 is 0.866. So 0.866. So now I just need to do that calculation and we'll be good to go. So for that, I'm going to use my post 901-163 model slide rule. 8 times 0.866. So I'll line the index up here with 8. There we go. Right there. Then I will move my crosshair to 8.65, a little bit 4 to 6. There we go. And it looks like my answer then should be 6.9 something, 9.2 or 3. Well, looky there, 6.93. There's my answer. 6.93. There we go. Excellent. Number 2, if the sine of alpha equals 12 over 13 and the cosine of alpha equals 5 over 13, then the tangent of alpha equals what? There's a couple ways we could do this problem. One would be to draw a triangle. So there's my triangle. I'm going to make that alpha. Now, the sine of alpha being 12 over 13 tells me that since sine is opposite of hypotenuse, that this side must be 12 because it's opposite, and this is my hypotenuse of 13. Similarly, the cosine would be adjacent, which is 5, over 13, which is the hypotenuse. So what is the tangent? Well, the tangent of alpha then is just going to be the opposite over adjacent, which is 12 over 5. There you go. Looks like that's that one right there. C. Now, another way you could have done this is by recognizing that the tangent of any angle, in this case alpha, is equal to the sine of that angle divided by the cosine of that angle. Tangent equals sine over cosine. Since the sine is 12/13 and the cosine is 5/13, when you invert and multiply, you get 12/5. So a couple ways to go about doing that problem there. Okay, 3. If x is between 0 and 90 degrees, and the sine of x is 1/2, then the cosine of x is what? All right, well, first off, what does it mean to say that x is between 0 and 90 degrees. It means that if this is a Cartesian plane, this is my 0 degrees here. And if I advance that angle up, 10 degrees, 20 degrees, 30 degrees, 40 degrees, by the time I get up here, I will be at 90 degrees. So that means my angle x is somewhere in that quadrant between 0 and 90. I'm going to put it right there. Let's call that, there's angle x right there. Okay. Now, I'm just going to make a triangle out of that. There we go. Now, again, sine is opposite over hypotenuse. So if I look at angle x here, I know that the sine is 1/2. That means it should be the opposite 1 over the hypotenuse 2. And Pythagoras can tell me straight away what this side must be. 4 squared minus 1 squared should equal, the other side should be the square root of that. But you might recognize this immediately right away as one of the more common triangles. This is a 30-60 degree triangle that has dimensions of 1, 2, and then root 3. So however you come up with that root 3, just a matter of now reading the cosine. The cosine is adjacent over hypotenuse, or root 3 over 2. Root 3, there it is right there, root 3 over 2, b. There you go. Problem 4. From a hot air balloon, there, the angle between a radio antenna straight below and the base of the library downtown is 57 degrees. If the distance between the radio antenna and the library is 1.3 miles, how many miles high is the balloon? Well, there you go. Now, this forms a triangle, as you see here, and what do I know about the triangle? I know what the length of this side is, and I'm trying to find the length of that side. I do not know the length of the hypotenuse. So I need to choose a trigonometric function that does not include the hypotenuse, and we have one very good candidate, the tangent. So the tangent of 57 degrees will be equal to the opposite over the adjacent. So it should be equal to 1.3 over the adjacent side. I'm just going to call that x over x. So again, just do some arithmetic here. I will multiply by x and divide by the tangent of 57. So that means x should equal 1.3 divided by the tangent of 57 degrees. That means x equals, well, I don't need that actually, because I see they left them in that same form. So I don't do any calculations there. There's my answer right there, C. There we go. Easy peasy lemon squeezy. What is the smallest positive value for x where y equals sine 2x reaches its maximum? Okay, now this is a trickier problem than the ones we've had so far. If we consider just the graph y equals sine of x, and if you've taken trigonometry, you should have this graph fairly well memorized. Okay. Starting here at 0, okay, and advancing to pi over 2, pi, 3 pi over 2, and 2 pi, or 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Sine goes as high as 1 and as low as -1. So it goes up here, down here, and then back up there. So it reaches a maximum at 1 and a minimum at -1. And it just keeps on going. I mean, this just keeps going forever, never, ever. Just so this is sine x. So what does this 2 here cause to happen? If I have y equals sine of 2x, how does that alter my sine of x graph? Well, what it does is it changes the distance, called the period, that it takes for my graph to start and make a complete cycle for it's back to where it started and begins over. So from here, it's 0 to 2 pi. By putting a 2 in there, that changes that from 0 to 2 pi to 0 to pi. And so here I'm going to just put a pi right out there. That means that this will be pi over 2. Halfway here should be pi over 4. And this will be 3 pi over 4. So this 2 causes my period to go from 0 to 2 pi to just 0 to pi. But nothing else changes. That's all that 2 affects. This is still going to go as high as 1 and as low as -1. And that means it's going to go from here to there. Oops, pass through pi over 2 and back up to there. So here's my maximum right here. And what is that value? Well, it's pi over 4. There you go. I suppose if you didn't know this, one way you might approach this is to use your calculator and actually plug these values in and solve for x. If you do that, make sure your calculator is in radian mode and not degree mode, or you will not get to the answer you're seeking. You could try that and see where it reached a maximum. But you still would want to know, of course, that the maximum it could only reach is 1. So all of these are going to be between 1 and -2. Oh, sorry, 1 and -1. Let's see, blah, blah, blah. Yeah. So that would give you the right answer, too. Just plug those values in there. So, okey-doke. All right. Oh, here we have number 6, a similar looking problem. One of the graphs below is that of y equals a sine theta. Y equals a sine theta. Now, in the previous problem, we had a number in here. Here we have a number out in front, a coefficient on my sine function. How does that change the basic sine function? The graph of sine of x, again, looks like this. From 0 out here to 2 pi. I don't have any value in here, so it's still going to go from 0 to 2 pi. Okay. Now, it says here between 0 and 6.28, well, as you know, pi is 3.14. So 6.28 is approximately equal to 2 pi. So that's just the full period. Zoom from 0 to 2 pi. So what does this do? Having a number out here affects how far up and how far down it goes. The standard sine graph goes from 1 to -1. If a is greater than 1, it will cause the graph to go higher. Say a is 2, it would go from 2 to -2. If a is less than 1, say 1/2, it would cause the graph to go lower. So it would be from 1/2 to -1/2. So that's what that value is going to do. It's going to change what's called the amplitude, how far up you go and how far down you go. So that means our graph, whatever a is either going to be less than 1, between 1 and -1, or higher than 1 and -1. And if we look at these 3 choices here, all of these still go from 1 to -1. So none of those can be the right answer. So I'm left with A or B. And B is the graph, but you'll note that not only does it still only go up 1 and down 1, but the whole thing's been moved up 3 units. So it can't be B. It's got to be A. So there's my answer right there. And specifically, actually, the capital A here is actually a value of 3. This is the graph of 3 sine theta. So that value out there affects the amplitude. And finally, last one here. In the right triangle below, the length of AB is 13 units and the length of CB is 12 units. What is the tangent of angle A? Well, here, of course, is angle A. Tangent would be opposite over adjacent. What is the adjacent side? Well, you could figure it out with Pythagoras' theorem, because 13 squared, 169, minus 12 squared, 144, will equal 25. That'll be square root of 25, which is 5. But we also just saw this same triangle just like a couple problems ago. And that's typical. There are certain triangles that show up again and again and again, like a 3, 4, 5. These are called Pythagorean triples, common triangles that show up over and over. And this is another one, 5, 12, 13. We also have, we saw another one earlier, it is 1, root 3, 2, And 1 root 2 is also another one. So it helps just be familiar with those common triangles, because on a test like the ACT, they show up again and again and again and again. So this, once I know this is 5, it's just a matter, what's the tangent? Well, it's opposite over adjacent, or 12 over 5. Done. A. Okie dokie. Very good.